Fantastic. Hello, everyone. This is Thursday, April 16th. Good morning. Hopefully, you're having a fantastic start to your Thursday so far, and you had a great day yesterday. Today, what I'd like to do for you for AP Computer Science A is I would like to go over the free response question that I asked you to try on your own at the end of last class, the one about the mechanical arm and the pH solutions. It's a little confusing only because I think of the context of the question. Once you actually get down to what the question itself is asking and what you actually have to do, I think it's much more manageable. And I think that's a big challenge of these AP Computer Science free response questions is being like, all right, what do I actually have to do? And then once you figure that out, you can say, okay, let me think about a couple steps as to how I can do it. All right. So these free response questions are really more like, in my opinion, problem solving, where it's just like, all right, let's figure out our first initial goal. Then let's come up with a list of steps as to how we can do it, and then we'll translate that into code. So last time I tried to walk you through a little bit of my mentality as to how I figure those things out. Some of you said it made sense. Some of you said it was a little confusing. I'm going to try to do a better job today of breaking that down for you one step at a time. So let's make that happen today. All right. So going into our free response stuff. So what I asked you to do was... Actually, we don't need the game club classroom. Let's get our classroom here. What I asked you to work on last class was this right here, where we did this tournament thing the other day. We're now going into this problem about a solution and being acidic and all that type of stuff, right? So I walked you through the problem the other day where I kind of described the outline of it to you. So today, I want to just go over how we actually get an answer. All right. So what's going on in this type of free response scenario is the fact that we have all of these solutions lined up in a row. So they're making an array list of solutions. Okay. Not only do they have the solutions there, but they also have the pH of each solution. And a solution is considered to be acidic. It says it right up at the top here if you see it. If it has a pH value from 1 to 6 inclusive. So that's really important. A pH from 1 to 6 is considered to be acidic, and anything else is just considered to be a regular old non-acidic solution. Okay? So it gives you a couple examples here. Hopefully you're able to read this. Hopefully you tried it on your own, so I don't want to go through it like literally word for word. Hopefully you're able to read this and understand the idea. So we have this mechanical arm, and like I told you last class, we didn't talk about interfaces only because that was cut from the AP Computer Science A exam as of last year. So just treat this like a normal, regular old class. An interface is different than a class, but for our purposes and for the purposes of this assignment, you can really just assume that it's a regular old class. So you have this mechanical arm that what it can do is it can get the current index, so it returns the current location of this mechanical arm. I think of like a claw machine. You could say whether or not it's facing right, true if it's facing right and false if it's not. You can change the direction of the arm, and then you can move forward the number of locations. The really important thing with this mechanical arm is that you don't need to know how these methods work. You just need to know that they work and what they do. Okay, so that's a really important thing when it comes to the AP Computer Science A exam, is a lot of times on these free response questions, it gives you these methods that do various tasks, but it's not your job to determine how those tasks actually end up executing. You just have to understand, okay, if I want the arm, for example, to change direction, so to turn around, I just need to call upon this change direction method. I don't need to code anything else more complicated than that. Okay? Now, what that mechanical arm is used by is this experiment class below. So we have our mechanical arm, which we call arm. We then have an array list of solutions, which these were the solutions up here, right? Solution has the get pH and set pH. An array list of solutions. The first method that we have to write is this public void reset. So when we write reset, what it's supposed to do is reset the experiment, meaning we want the mechanical arm to have a current index of 0. So this mechanical arm is going to be somewhere in the list, and we need it to go back to the beginning. And then we also need it to face right. Okay? So how do we actually do that? Well, let's look at what the mechanical arm can do. We can get the current position of it. We can make it turn around by saying, well, if it's facing right, then that's good. If not, then change direction. and we can make it move forward by a number of locations. So those are the like functions that we have available to us, and we have to accomplish getting it back to index 0, turning it around if necessary, and that's really it. That's how we reset the experiment. So how can I get it to do that? Well, what I can do first is think of the list going in a linear fashion from left to right. Just like you see in all these examples, you see this list going linearly like this. Okay? So what I need to do first is I need to say, well, say my arm is over here at 4. I actually think this diagram is a great example. We need our arm to turn around. We need it to go back to the beginning and then turn back around to the right. Okay? So I'm going to first start out by saying, when we're trying to reset our solution, I'll say if what is it, is facing right, I believe is the main, yeah, if is facing right is true, right? And since we're calling the arm the mechanical arm, I need to say arm dot is facing right, because that's the name of our mechanical arm. Where is it? Right here, arm. If arm dot is facing right is true, then we need to turn it around because we need to backtrack to the left, right? And I believe the method to do that is arm dot, where is it right here? Change direction. So you say arm dot change direction. Okay? So this ensures that the arm is now facing to the left. Okay? Now that we're facing to the left, we need to backtrack back to the beginning. How do we know how many spaces to backtrack? Well, we can actually just use the value of the index that it's located at, right? So I can use this method of the mechanical arm called getCurrentIndex to say I want to backtrack that many spaces, because if it's index 4, right, I'd want to move 1, 2, 3, 4 back to the beginning. Does everybody see that, hopefully? So I'd want to just say arm dot, and what's the method called? Move forward. And I want to move forward by this value, getCurrentIndex. Because that's going to progress the arm to move forward that way. Does that make sense to everybody? Okay. And then last but most certainly not least, we need to make sure, so now we're back at index 0, so we've moved forward back to index 0. We just need to make sure that we turn around again because we want the arm to be facing to the right. So what I'm going to now do is I'm going to say if arm dot is facing right is false, meaning it's now facing to the left, then I want to turn it around to get it to face to the right. Okay? And that should accomplish my goal, right? If you look at the post condition, the mechanical arm would now backtrack to 0 because that's exactly what this line does. It backtracks it to 0, and it makes sure it's facing to the right at the very, very end. All right, so this would be the code that I would use. Again, not the only solution, but that is the code that I would use to accomplish that. Does anyone have a question on that? Okay. Now this method is a little tougher. What we have to do is we have to find and return the index of the most acidic solution. So we want to return the index at the location of the most acidic solution, or -1 if there are no acidic solutions. All right. So we've done programs where we're trying to find the lowest value in an array list. This is kind of a twist on that, where I want to find the lowest value in an array list, but only if that value is between 1 and 6 to signify that it's an acidic solution. So what I would do first in order to do this, you try to think, like, how can I go through the whole list and check for the one that's the most acidic? What I think I would do is I would probably reset the experiment right away. So we wrote the reset method right here, and I would definitely make use of that. If you notice on the actual directions, they give you the list of things to actually use, which is super, super valuable, right? We could actually go ahead and use these methods right here to accomplish that, okay? And again, this most acidic method is what we're doing in part B. So it gives us this nice list of like, oh, you have all these tools at your disposal to make that happen. So the very first thing I think I would do is reset. So that means we're at the beginning and facing right, okay? What I'm going to do is I'm going to say, since we're returning an integer, let's say we're going to come up, because see how it's returning an integer? We're going to try to find out what that integer is. So we're going to say int, we'll call it most acidic, if I can spell acidic, is equal to -1. The reason why I'm starting it at -1 is because if we don't find an acidic solution, I want to return -1. So yes, you could start it at 0 and then reset it to something else later, but it makes sense to start it out at -1. Okay? What I then want to do is I want to progress through the list. So that's pretty easy. I can say for int I is 0, I is less than, I believe it's called solutions. It is right here. Solutions dot size I plus plus, meaning we're traversing the list, right? I now can say if we find a solution at dot get I dot, and I believe the method is called dot get pH. Yep. Oh, and you know what? Now I'm realizing as I'm writing this, we're probably going to want it to be less than this. So I want to say like if, I want to say like if it's less than this. So you know what I could do is I could maybe start this at 7, because the reason why I could start at 7 is because we could say that our acidic solutions are 6 or lower. So we could say if this solution dot get pH is less than most acidic, right? I could now say most acidic is equal to, let's see, I could say most acidic is equal to this pH, because now we'd say that's the most acidic value. And that's how we could go through the whole list to find out which value is most acidic. Okay? Here, I could now say if most acidic is still 7, then we can return -1. I think that would work out nicely. Do you see that? How we can go through the whole list to find out which one is most acidic. If I find that we never triggered the condition of being the most acidic, then I can go ahead and return this value of -1. Does that make sense? How we're going through the list now? So this value of most acidic will now contain the value of the most acidic solution. Okay? So if I didn't return that -1, that means that we did find something that was acidic. So now what I can do is re-go through the list and say, like, where is that specific thing? Yes, I could say, like, where do we actually find that value, and then return that index. And I'll just go back in a little bit and actually say, like, how do we move the arm in such a way, right? So we'll get to that in just a minute. Okay? So I is less than solutions dot size I plus plus. Okay, I can say if solutions, I think, dot get at index I, dot get at index I dot get pH. I can say now if it equals most acidic, meaning that we now find that, I want to return I. Okay. So again, certainly not the only way to do that, but that's just the way that I'm going about it, where I'm saying, well, let's start by saying, let's assume the most acidic solution is 7, which would mean that we never find an acidic solution. As we go through the list, if I find something that's more acidic than that, well, let's set it to be that. Otherwise, we can return -1 if we never found that. But if we get past this point, then that means we did find at least something. So we can now go through the list. I can say, let's get the pH of, if I can now say, let's look for where that specific value is and return that value. Okay? Now, what that does not take into account, so that's the general logic. What that does not take into account is the mechanical arm. So the fact that we really want the arm to move to that specific position, where I can say the mechanical arm is facing right, and its current index is at the most acidic solution, or at 0 if there are no acidic solutions. Okay? Notice, arm.reset put the arm at index 0, right? That's what we wrote up here, correct? So if this goes through the whole logic here and doesn't find anything, then that arm is still going to be at index 0 and facing right. So we really don't have to worry about the arm yet. It's only here now where I want to now move the arm forward. So what I can now say is its current index has to be at the most acidic solution. So once I find something, I want to do arm.move forward. And by the way, we already know it's facing to the right because that's what reset does. Yes, it's called move forward, right? And I want to move forward I spaces because I want to move to whatever that index is. Does that make sense to everybody? Because I want this arm to progress to wherever I find that most acidic solution. Yes? And that mechanical arm will be guaranteed to face right because we reset it, meaning that it's already facing to the right. It's just going to bounce forward that many spots. Okay? So that's the code that I would write for that particular response. Again, certainly not the only way that you could do that. But does that make sense to everybody how we did that? Yes? Does anybody have a question on that problem? Mr. Ferrer, does that check out in your mind, do you think?
Yeah, that makes sense.
Oh, it makes sense? Yeah? Okay, good. Good. It's good to have somebody to double check. Excellent. All right, so I think that's, again, the important thing about these free response questions. Figuring out, first of all, what is it requiring me to do, and how can I go about it? With our reset method, we wanted to say, well, we need the arm to be back at index 0, and we need to be facing right. We can't just say, move the arm to 0. We can turn it around and tell it to go forward or backward that many spaces, right? If we turn it, move it, turn it, move it. So what I did is I said, well, let's make sure it's facing to the left. Let's move it forward by whatever the index is, and then move it to the right, face it around, right? Here, what I did is I searched through the list to find the most acidic solution, the one that had the lowest pH. If we didn't find anything that was categorized as acidic, then we just returned this -1, which it told me to. Since the arm was reset at the start, that means it is at index 0 if there are no acidic solutions and facing right. Since if we did find something, though, I'm going to move it forward and then return whatever that index is. Okay, searching for wherever it is. All right. Any questions, comments, concerns about that? Okay. I have another example that I'd want to show you today. This one is free response sample problem 2. I believe I uploaded it on Classroom. Oh, no, I didn't upload this on Classroom, but I uploaded the PDF on Classroom. So let me show you that right now. So I uploaded, not that, that's homework. I uploaded, it's down here, there it is. I uploaded this on Classroom, okay? There's a little cutoff of the previous problem up here, so you can ignore that. But I think this is actually an excellent example for a free response question that could use arrays and array lists and all the type of stuff. So this AP question says a word creation game. Can't say Scrabble. Can't say Scrabble. I'm going to say it. They can't say it. A word creation game uses letter tiles, each of which has a letter and a numerical value printed on it. So you get, I don't know if you ever played a game like Scrabble, you get letter tiles, they all have little points. So that's the idea. Partial implementation of the tile class is shown below. So very, very simple, straightforward. We have this thing called a tile. It has a letter and it has the value, and we can get the value and get the letter. Okay, quick, easy, no problem. All tiles for the word game are called the tile set, which is represented by the tile set class, whose partial implementation is shown below. So it says we have this thing called tile set. Tile set really contains this array list, and again, like I told you, a list and array list are really interchangeable, of tiles that contains all the tiles in the word game, both used and not yet used. Okay? Unused size is the number of tiles that are not yet used. So we have this thing called unused size. It determines if there are still unused tiles. So this method right here returns true if all the tiles have been used or false otherwise. So that's all that little method does. That's another tool that we have in our pocket. So we can say that we can figure out if there are any unused tiles left. It also returns the number of unused tiles in the tile set, so we can actually find out exactly how many unused tiles there are. That's another tool that I have. We are going to write this method called shuffle, which shuffles the tiles in the tile set and then resets unused size to the total number of tiles in the set. We have this other thing that we're going to show, or that we can use to say get a new tile from the tile set. It returns an unused tile from the tile set. Okay? We don't need to know how that works. We just need to know that it works. I can use this method whenever I want to get a new tile. I want to pick a letter from the bag. I can say get new tile. Okay? Keep in mind that it will return null if all tiles have been used. All right? So our first task is to write a shuffle method for the tile set class. It says our method should use the following algorithm. For k, starting at the end of the tiles list and going down to 1. Here's what it wants us to do. Pick a random index from 0, 1, 2, all the way up to k. We can do that with math.random. Swap the tiles at position index and position k. We know how to do that. Swap two positions in an array. And then reset unused size to the number of tiles in the tile set. Okay? Keep in mind, all we have to do in order to do that is just get unused size. Right? We don't actually have to, I don't think we actually have to change that at all. We just say get unused size, and it tells us what the unused size is. All right? And that's the important thing. Like, we don't actually have to, like, figure that out in the sense that I don't need to figure out how many tiles are used and how many tiles are unused. We have this method called get unused size, which tells us that. Okay, so that's a very important thing to keep in mind. I find that, at least looking over some previous AP Computer Science A sample questions and answers, a lot of students will get confused with something like this because they'll be like, well, how the heck am I supposed to change unused size to the total number of tiles? You just have to say unused size or get unused size. That's it. Okay? If you really want to change it, you could change it to be the size of the list, I guess, if you really wanted to. All right? So let's go ahead and actually create this algorithm, right? So I did a little type up over here of all this stuff for you. Something to add to your notes if you do not have it, I almost guarantee that you'll need it for the AP Computer Science A exam, is this math.random formula. This is how you find the random number, how you have a program generate a random integer within a range of numbers. So I highly recommend using it. Okay? To actually implement this shuffle method, right? Let me change it to our good old font here. Let's see. Well, what does it want us to do? It wants us to say for k, starting at the end of the tiles list and going down to 1. We could literally translate that. For int k equals, what's the name of the list? Is it tiles? Yeah. Tiles. Tiles.size minus 1, because that's the end of the list, right? Remember, we have to subtract that 1 so we don't go out of bounds. We could say k is greater than 0. That would mean we're at the end, yes, or greater than equal to 0. And then k minus minus. So we're going to start at the end of the list. We're going to go back to the beginning. What I want to do first is I want to pick a random index from 0, 1, or 2 to k. So using our math.random formula, yes, we're going to pick a random index up to k. So from 0 to k. I'm going to say int random number, or whatever you want to call it, equals int math.random. We're going from 0 to k. So times, I'm literally just copying the formula right above me. From 0 to k. K is my max, 0 is my min, so k minus 0 is just 0, right? Plus 1. So I can do times k and plus 1, and then plus the minimum, which is 0. So we really don't even need to add that. So I think really we're just looking at that, right? Actually, let me copy the formula exactly, just so I don't confuse people. K minus 0 plus 1, and then plus 0. Okay? You see how that would work out? Yes, you can simplify that down to just k plus 1. This. Kind of like that. There we go. Yeah, we can simplify all that plus 0 and stuff down. That will make sure that we get a random number. That's just following the math.random formula. That will make sure that we get a random number from 0, 1, or 2, or whatever to k. All right? So what do I want to do with that random number, according to this? Swap the tiles at position index and position k. So we get this, I guess they call it index, so we can call it that. Okay? We can get this thing from there and from position k and swap. Remember, to swap, what we have to do is we have to store in a temporary spot so we don't lose the data, and then translate it. So first I'm going to say, since it's a tile object, called tile, right? Temp tile equals new tile, and we want to use the tile list. Is that what it's called? Oh, it's just called tiles. Tiles at dot get k. All right. So I stored the tile at index k. I can now say tiles.set at index k. We want that to now be tiles dot get index, right? We want to get that index, whatever that's generated. I want to set k to be that. And now I could say tiles dot set index to be temp tile. All right. Does everybody see how that works out? Hopefully. Yes. Now, in order to actually reset unused size to the number of tiles in the tile set, I guess what you could do, I guess what you could do is you just count what k is. So we could say like, yeah, we just count like how far that gets. So we can just say, that's quick and easy. We don't even have to do anything. I was getting all like bent out of shape and I was like, whatever. We don't have to do that. We just say unused tiles, that's the name of the variable, right? Or unused size is equal to the whole list, tiles.size. Minus, I think just tiles.size because we just want it to say like, does it have, I guess it would it be -1 for tiles.size or just tiles.size? I'm trying to think. Tiles.size is technically one more, or I guess it's not really one more than the number of tiles. I think it might just be that. Okay? So that would be the code that I would do to actually execute that algorithm. Does that make sense to everybody? Okay. We have a couple other methods down here too. We have this thing called replace tiles. What it wants us to do going forward from here is it wants us to say, we have a player class who uses the tile list and all that stuff. So in this player class, we have the number of tiles is just some integer that they're allowed to store that many letters. It gives us this array list of tiles called player tiles. And what this method is going to do is it's going to add a sufficient number of unused tiles from tile set to the player tiles so that this player has number letter of tiles. So in other words, once you play a word in something like Scrabble, you use up your tiles and you always refill back to whatever the number is, your limit is. In Scrabble, that limit happens to be 7. Okay? So they should, if there are less than that many unused tiles, the player should take all the remaining available tiles. So your precondition is that their player's tiles.size is less than the number of letters, meaning that we've played a word, so now we have fewer tiles than the number of letters that exist, and we want to make sure that we have less than or equal to the number of letters that we're supposed to have. Okay? So, and T is the tile set for the word game. Okay, so that's the tile set. So what I can do here, I'll do this one quickly with you, is I can say, well, first of all, I know I have less tiles than what I need, so let's go until I refill back up to my number of tiles. Do I know how many tiles I have? No, not necessarily. So I can say while player tiles, that's what it is, right? Dot size is less than number of letters. Correct? So I can say as long as we have fewer tiles than how many letters there are, then I can say, well, let's add some tiles. So how do I get a tile into my thing? Let's see. Can I just say, can I say T, because T is the tile set, right? How do I add a tile? Is there a method that does? Oh, right here. Ooh, look at that. T.get new tile. Perfect. Perfect, perfect, perfect. Get new tile. So I'm going to say T.get new tile. That means it's going to give me a tile. Now I want to take that tile and I want to add it to my player tiles, right? So I can say player tiles dot add T.get new tile. Bam. That was a tool that was given to us, right? So let's add that new tile. So that's all well and good. That'll work just fine. But now what if there just so happens to be, like, what if we get to the fact that we run out of letters, right? What if we run out of letters? Okay. Well, that would be very bad. So what I want to do here is I want to say if T dot, or I could say, actually, we can do this. Tile T equal, or tile, we'll call it temp tile equals new tile, and we'll say T dot get new tile. It's one way. This is the way that I'm thinking of doing it. We could say if temp tile is null, meaning that we've now run out of things. Could say break, meaning that we want to end the while loop. And then we could say player.add t.get new tiles. I think that would work out just fine.
You could also add something to the while loop too, right? To say while.
Oh, true.
And unused size is greater than unused tiles. That's is greater than 0. Yeah. Whatever the
is like
was
greater than 0.
unused tile.
Yeah, something like that. Absolutely, I like that, Mr. Ferrer. That's absolutely true. So we can add it to the while statement to say, what is it actually called here? Get unused size. Oh, there's actually this method called all used as well. So we can say like t dot all used.
Yeah, or not all used.
Yeah.
Right. No.
Is false, something like that, or not all used or whatever. Do you see how that could work too? So we wouldn't even need this in here. We could just say something like this. Actually, and we wouldn't even need this statement now. We could just say just that. Yeah, that would work out nicely, right? I think that works out nicely. Do you see that? Hopefully everybody sees that. So we're going to keep adding tiles as long as we have fewer letters than we're supposed to, and we haven't run out of letters, then keep adding letters. Otherwise, we would stop. Like if we either ran out of letters or we got to the number that we needed. I like it. We are out of time. Unfortunately, we've gone a little over, so I'm not going to be able to do the get word score. I think that's actually a great method, though, if you want to try to do it on your own, where essentially you're just adding up the actual score values of the letters that you play. I think that's a great one to try on your own. Maybe I'll do it at the start of next class. I probably will. I'll do it at the start of next class. Okay. But again, hopefully you noticed in my little thought process here and Mr. Ferreira's additions that what we really did is we just made use of the tools that we had available to us. I said, well, I need to be able to figure out whether or not all these tiles have been used. Well, I guess Mr. Ferreira said that. And so what we did is we looked up here and we said, do we have something that tells us that? And we said, ooh, we have this method called all used. So let's just use that to figure out, have we run out of tiles? I need to add a new tile to the player list. Do we have a way to get a tile from this tile set? Oh, we do, right here. A method called get new tile. So it's probably a good idea at the very start of one of these free response questions to keep track of the tools that you actually have at your disposal. And then once you have what those tools are, figure out how you can use them to accomplish the goal you're looking for. Here, they actually gave us the algorithm that they wanted us to do, so it was just a matter of translating those steps into code. Here, we had to kind of translate those tools into code. Does anyone have a question on anything I just said? Mr. Ferrer, I don't know if you have anything to add while you're here.
No, that's all good.
Made sense, yes? All right, I appreciate you guys staying a little extra. What I'm going to ask you to do for next class is, you may have noticed, I did upload, let me zoom out a little bit. I did upload an assignment here for you. These are the free response questions from the 2017 AP Computer Science A exam. I would like you to try to do questions 1 and 2 for the start of next class. They are, as I wrote here, they're excellent questions that emphasize array lists and classes, which just coincidentally happen to be the topics that we're going to see on the AP exam. So I think those are great practice problems for you. I also very quickly uploaded down here the free response questions from past AP exams. You can go ahead and freely access this link from all the previous AP Computer Science A exams. You can dig through all those free responses, see some sample responses, see how it's scored, all that stuff. You can find some actual sample responses here for the 2017 ones, which is what I attached for you. Okay.
Do I have access to this?
To this Google Classroom? I don't believe so. I will.
Can you just send me one of the practice tests? I'm just curious. I want to.
Yeah, I'll email you. I'll send you this link.
Thanks.
No problem. Anything else? Like I said, ladies and gentlemen, I appreciate you staying a little later. I think it's important to go through the actual thought process for those types of questions. If you do have any other questions, please feel free to reach out. Okay, please do not hesitate. But thank you so much for your attention and focus, and I will see you guys Tuesday. Wow, it's a long stretch of time, so have a good weekend. Enjoy your time. Plenty of time to get those problems done, and I'll see you then. All right, thank you.
See you, Giorgio.
Goodbye, Mr.
Bye,
Giorgio.
Mr.
Later.
Giorgio.
Have a good afternoon, Mr. Giorgio.
See ya.
Bye.
See you later.
Good afternoon.
Great afternoon.
Have a great afternoon.